backup in the slides with all the code. So I'm Yevgeniy Brikman. I also go by the nickname Jim. And I'm a software engineer at LinkedIn, part of our service infrastructure team. And I'm the lead on the project that's bringing the Play framework to LinkedIn engineers and hopefully making them nice and happy. We got our first Play app into production about a year ago. And at this point, we have about 60 apps at LinkedIn, front ends, back ends, internal tools, a whole bunch of different stuff. Some of the ones you may have seen include LinkedIn Channels, which is part of the LinkedIn Today product, Recruiter Mobile, which makes us a lot of money, LinkedIn Jobs. This is my subliminal message to tell you that we're hiring. Polls and Groups. This was actually one of those very, very first apps that we did. Play Labs for experimental apps, such as this In Demand. And a whole bunch of internal tools. Play makes it really easy to get started and get going. And so we've just seen a lot of engineers just pick it up and build little tools, little one-off apps all over the place. This one we use for searching all the RESTful APIs inside of LinkedIn. Also a whole bunch of backends. I don't really have a sexy screenshot to show you for those unless you like looking at JSON, but a whole bunch of backends built on Play as well. So we love Play, but we found one or two tiny little problems. So one is unmanageable complexity, and the second one is just terrible performance. Some of the type-safe guys are probably going, what the hell is this guy doing? I thought he was going to be nice. But don't worry, it's probably not what you think. I'll discuss a little bit closer what I'm really talking about in a minute. And this talk is about a couple techniques that we've been experimenting with to deal with complexity and to get some really nice performance. And the techniques are fairly experimental, so this is your disclaimer, your mileage may vary, all of that good stuff. But they're a lot of fun, so I recommend that you grab this stuff, go play with it. The code, the kind of a sample app that I'm using here, is on GitHub if you want to grab it. This also has a link to this slide deck. So this is the GitHub repo, and then the slides are on SlideShare if you want to follow along or look at them later. All right, so this is what we're going to be talking about. We're going to talk a little bit about complexity, and then how composition and HTTP helps us deal with it. And then we're going to talk a little bit about performance and how enumerators and streaming can make it work and can make it a lot nicer. So we're going to start with complexity. When I say that things are complex, what I really mean is the web pages that we're building are getting seriously complex. If you look at something like the LinkedIn homepage, Facebook homepage, any of these kind of big sites, you know, at first glance they look like just like a bunch of markup, but they're not. There's actually a whole lot going on here on a single page. Everything from these shared nav, dynamic ads, a type-ahead search, notifications, premium customizations, people you may know driven by Hadoop jobs, news feed powered by a relevance engine, to LinkedIn Today articles, so on and so on and so on. And there's just a lot here. And to make it even more complicated, what you see, which modules you see on the page is dynamic. So a new user might see a bunch of modules encouraging them to grow their network, whereas somebody that already has 1,000 connections might see more news or shared articles, things like that. So even which modules to show is determined dynamically. It's really complicated. If you try to cram this into a single controller and a single template, it becomes completely, totally unmanageable. You try to make a change over here, you break something over there. You try to deploy, you find a new bug. You try to write tests. I mean, here, go come up with a test plan for that. Good luck. It gets really messy, actually. A fun anecdote is, I don't remember if it was the home page, it might have been a different page. It was originally built with Spring MVC and JSPs. And the JSP for the page was so big that when it was compiled into a Java class, it was bigger than the maximum size allowed by Java. So you can't just cram this into one thingy. It just doesn't scale for apps that get sufficiently complicated. So we need tools to manage this complexity. And I mean, managing complexity, it's at the heart of what software engineers do, and we need better abstractions to do that. And that's really, these are our two tools that we use to deal with complexity. Abstraction and composition. These are sort of a yin and a yang. They're very related to each other. So abstraction is the ability to focus on some small part of the problem and safely ignore the rest of it. And safely is the key word here. And we do this all the time. I mean, if you think about a house is actually extremely complicated. if every time I thought about a house, I had to think about the fact that it's made out of wood and bricks and metal and wiring and pipes and glass and every single, I couldn't get out of bed in the morning. But when I think about a house, I think about an abstraction for a house, some little box, and that's enough, and I can safely ignore, most of the time, all the little details. And composition, it's sort of very, very related. This is the ability to take these small, simple pieces and set them up in such a way that we can then glue them together into more complicated behavior. And I think this is a beautiful illustration of abstraction and composition. A car is an enormously complicated device, but we're able to deal with it by breaking it up into tiny little pieces that are very simple. And you assemble a couple of them and you get a crankshaft, and you assemble a couple and you get the whole engine, and you assemble a few more, so on and so forth, until you get a full, complicated car. And so this is a very important tool that we can focus on little pieces to build bigger ones. And that's our goal. We want to be able to build a website as complicated as the homepage, where a developer can focus on one tiny little piece of that world and be comfortable that he's not going to affect the rest of it. But you need to write your code in a way where you can still then glue them all back together. So let's talk a little bit about how we can do composition. And what we're going to do is we're going to build this very, very simple part of the LinkedIn homepage called Who's Viewed Your Profile. It basically shows you, it's kind of this nice vanity metric, how many people looked at your profile and how many people searched for you. And to build something like this, we typically need a few things. One, we need some data. Usually we'll call some services to fetch this. We need a template to render the HTML, and we need a controller to tie everything together. Now, normally at LinkedIn, we have this big service-oriented architecture. We'd have to fan out to all sorts of back-end services to fetch all the data. But for the purposes of this talk, that's not really the interesting bit. So we're just going to use this mock endpoint. So let me quickly show you what that looks like. Can you guys read that? Cool. So this is a mock endpoint. It's in the Play app, and basically it's really ghetto. You give it a service name, so the Who Viewed My Profile service, search service, like service, and it's going to respond with some fixed data, in this case just a number, after some fixed delay. So right now they're all going to respond within 1 millisecond, so really quick. And so this will let us tweak some of these parameters and see what happens to the code that we write. Obviously in the real world, this would be a real service. It returns JSON, something a little more complicated than just a number. But for now, this will do. So I also, just so you don't have to sit and watch me write too much markup, I have the template for this thing here. This is a Who Viewed My Profile template. It has a little bit of CSS. It calls a partial to render the body. That guy renders some more markup, calls some other partials, and those render the actual counts. So basically a bunch of HTML markup. Nothing particularly magical. All right, so let's create a controller and put all of this together. We'll create the Who Viewed My Profile controller. That'll extend controller. And controllers consist of a whole bunch of actions. And an action needs to return a result, like a 200 OK that says hi or something like that. But we're going to return something a little more interesting here. So we need to call out to a couple services to fetch our data. And I have this really simple kind of service client. It calls that mock endpoint, given a service name, and it's going to return the body of the response, so basically that string, that number 56 or 10. And it returns a future. If you haven't used Play, Play is fully asynchronous. It's fully non-blocking. And so you don't get a result back from your HTTP client. You get a future of that result, something that will eventually contain the data that you want. So let's make a couple service calls. Oops. All right, and we get back, as you can see here, it's a future that'll contain the data that we want. So we're going to make two service calls, one for the Who Viewed My Profile count, one for the search count. And so we have two futures. These calls are happening in parallel. And then we're going to use a for comprehension to compose them together. I'll explain what that means in just a second. Okay, so basically this says when both of those futures complete, execute the code that's in here. And in here, what we're going to do is we're going to render our template. So views the Who Viewed My Profile. And we'll pass it those, we'll just convert them to integers, really ghetto. And there we go. Now we can get rid of this guy. And since this thing is returning a future, we have to tell Play that this is asynchronous. Okay, so this is a controller, call to services, render a template. Let's add it to our routes file. You can see I already have one other endpoint in there. I'll come back to that one in a minute. Call that guy. Okay. And I think I need execution context in here as well. All right. So let's give this a try. And, oops, what happened here? Oop, wrong package. Okay, there we go. So we have our little Who Viewed My Profile module. It called a couple services, gathered the data, and we rendered it in a template. So that's one module. This is one tiny piece of the LinkedIn homepage. Let's say we had another tiny piece of the homepage that looked like that. This is Who Viewed Your Updates. Very similar idea. It shows you how many people liked and commented on the things that you shared. How can we glue these two guys together? How can we build one page out of them? There's a bunch of different ways to do this. You could come up with your own protocol and have them implement some specific trait, return specific stuff, and do all these things, but you don't have to. In play, a controller consists of a bunch of actions, and the actions, if we actually look at the trait action, when you use them, you're basically using the apply method, this guy right here. And the apply method is just a function. It takes in a request, an HTTP request, and it returns something that will eventually contain the result. Well, it's a function, and functions compose, as Sadek told us quite a few times yesterday. So we can actually just call these endpoints and glue them together. So let's give that a try. We will create a new controller. We'll call it the aggregator. It'll extend controller. I'll have another action in here. Takes in a request. And now we're just going to call those other endpoints. Let me just return some mock data just so IntelliJ stops complaining for a bit. And so we created this Who Viewed My Profile controller, and it just has a method on it called action. Index. And we pass it a request. And if we do that, what we're going to get back is a future of a result. This is exactly what we need. This is the result that that page built. So we can call that. We can also call the Who Viewed My Updates endpoint, which is here. And I'll explain why I need that extra parentheses in a minute or two, but for now we'll just ignore it. Okay, and so what I've just done is I've called these two endpoints, and I get back futures that'll contain their results. And we know how to compose futures. It's exactly the same as we just did before. So here's Who Viewed My Profile. Here's Who Viewed My Updates. That guy. And we're going to return something. And if you look at the types of these guys, they contain results. Now, before the talk, I put together a bunch of little helpers that I'll be using throughout. One of them is this little guy called pagelet, and I just added a method to it that can take a simple result and give you back the HTML that this thing was going to render. And you can see it's literally a one-liner. It uses an iterative, and I'll come back to what iteratives are later, but suffice it to say that this thing just consumes whatever that endpoint was returning. So to pull out the HTML, we just call pagelet.readBody, and we give it that result. Do the same thing for Who Viewed My Updates, like that. And now in here we can render them. And for now I'm just going to spit them out as strings, just so we can see what we actually did here. HTML, dot toString, and we'll add the other guy in here as well. All right, get rid of that. This is asynchronous, and we need an execution context. All right, so now let's go add this guy to our routes file and see if it actually does anything interesting. Aggregator.index. Okay. And I'm actually going to use curl on this guy, just so we can see the exact markup that it's returning. What did I call it? Aggregate. Okay, so we got back a bunch of markup. And if you look, the Who Viewed Your Profile data is in here. and the who viewed your update state is in here. So we just glued together two modules. Now there is one minor problem. They both include the full HTML markup, which is not great. So we do have to make one minor tweak to these guys to tell them, look, you're being embedded in another page. Don't render everything. So to do that, we'll go into this who viewed my profile guy. Oops, not that one. Here we go. And we just give it a function parameter to say, hey, you're being embedded. It's a Boolean. And if it's being embedded, what we will return, let me just do an else. So if it's not being embedded, we return the exact same thing we did before. If it is, we're just going to render the body of this guy. And so just as a reminder, that template, as you can see, called another one that has just the body of the response, just this part. And the who viewed my updates controller has exactly the same thing. That's why I had to do those extra parentheses. It has this embed parameter in it. So now, if we go into our aggregator, we can say embed equals true. And here we can say embed is true as well. And why are you unhappy? What's going on here? Oops. Not actually sure why this thing is not happy. Anybody see the obvious mistake? We do need to update the routes file. Let's do that really quick. So we need to add that embed parameter in the routes file. Oops, not to this guy, to that guy. Oh, okay, apparently it wanted that. Okay, so now we're telling it to just return the body of the response. So if we look at what we get now, that looks more like it. So now we get the HTML markup that we wanted. Who viewed your profile and who viewed your update. So we can wrap these now in some sort of an aggregator template, and we're done. Let's do that really quick. Create a new template. Aggregate.scala.html. It'll have some HTML, something in the head, something in the body. So in the body, we're going to want to put the HTML from those two other endpoints. So who viewed my profile and who viewed my updates. And we're just going to put one after the other. Who viewed my profile and who viewed my updates. And for the time being, I'm just going to copy some CSS into here, and I'll come back to how to fix this in just a minute. So we grab this guy, do that, and now let's render our template. Views.html.aggregate, and we give it that HTML and that HTML. Okay, let's see if that looks all right. Looks good. Let's actually open it in the browser so we can see what we did. And there you go. So we just glued together two modules. We just did composition. We have two completely standalone play endpoints that render HTML, and we glued them together. Why would you want to do this? What is the advantage here? Well, if you go back to what the LinkedIn homepage looks like, it basically consists of, let me see if I can get it. Here we go, this on the right. It basically consists of a bunch of these modules. And what I've just enabled myself to do is to write them completely standalone from each other. I can write one, focus on one, write the tests for just one module, right? Writing the test for the entire homepage is pretty hard. Writing the tests for just this guy, very, very easy. You know exactly what data, what markup, you can check every kind of error case. So this really gives us some nice abstraction. So let's go through, and we will skip down to here. Okay, so we get really good abstraction, you get really good composition. These little pieces become reusable all over your site. Once you've built them as standalone endpoints, you can use them everywhere else on the page. So if that who viewed your profile module ends up on the profile page, you just aggregate it in, you just pull it in as another endpoint. You don't have to rewrite it. And testing on iterating on something small, and this is really important, it's dramatically easier to test and iterate on something like that. Now, some of the caveats. You have to be careful with duplicated service calls. So you can imagine every module on the page calls the profile service. But you can actually deduplicate requests very easily. It's a good practice anyway, and we do it. So this is very solvable. You have to deal with static content, as I mentioned. I'll come back to that in a minute. And okay, so let's talk about why HTTP is useful here. So I glossed over a few details. If you looked at the code that I just wrote, you're hopefully asking a few questions. So for example, one, how do you set cookies? If the who viewed your profile thing needs to set a cookie, how does it tell the aggregator I need this cookie? How do we handle errors? What if you're really unpopular and nobody looked at your profile? We don't want to show the modules. We don't want to show you a bunch of zeros and make you feel bad about yourself. It needs some way to communicate, don't show me, I don't have any content. And once again, how do we handle static content? So all of these can be handled really nicely using HTTP. So I'm not going to code this part. I'm just going to quickly show you some slides on it so I can get to the performance section and still have enough time to show you some cool perf demos. So this is our who viewed my profile controller, and if it needs to set a cookie, well, it can set a cookie the normal way you set cookies in Play. And if you do that, that gets set as an HTTP header. And if it's set as a header, then my aggregator can read it. So this is the aggregator. If you look, what this guy is a simple result. If we open that class, you can see it has the response header as one of its visible fields. And inside of there, here's all the headers, including the set cookie header. And so we can actually just read it in. If we were going into our aggregator, we can have this little bit of code that, given a bunch of results that we're aggregating together, it can basically loop over them, read the set cookie header, and merge them all together. And if you do that, then your aggregator can include those cookies in its response. Okay, so cookies are no problem. It just works with normal HTTP. What about error cases? Well, it turns out HTTP status codes are a really effective way to communicate error cases. So for example, that case where nobody looked at your profile, well, that's a 204 no content. The case where there's some sort of an error and somebody requested the wrong module, that's a 404. And there's lots of other fun status codes if you go through the spec. There's, 414, request URI too long. And then this is my favorite, 418, I'm a teapot. This is apparently what you get from Stack Overflow if you mess with their CSRF mechanism. So HTTP status codes work really well for handling these cases. And the aggregator can read the HTTP status code. If it wasn't a 200, it can do something intelligent like not show the module. For CSS and JavaScript dependencies, there's no natural built-in way to communicate these, but there's no reason you can't put them into a header. So we could define something like this XCSS header and XJS or whatever you want to call them, and you could just put the URLs of the CSS and JavaScript that your module depends on. So you could have some code like this where you say, I need this CSS file, I don't need any JavaScript, and you just include them as headers in your response. Once again, if they're headers, the aggregator can read them back in, merge them, dedupe them, and include them in the aggregated page. It feels a little clunky, but actually explicitly calling out the dependencies of each part of your page is an incredibly valuable exercise. If you're using require.js or something similar, you're probably doing a little bit of this, but try that for every CSS file, every JavaScript file, and you'll see some amazing results. This actually makes your code dramatically more maintainable. So once you put this thing all together, your modules are really standalone. You can really use them from anywhere. So for example, in our aggregator code here, we're hard coding which controllers to call. But remember how I mentioned the LinkedIn homepage dynamically decides which modules to show? We actually have a system that kind of measures users' behavior and sees what they're doing and recommends the modules they should see. And those recommendations consist of URLs. So there'll be a URL like /wvyp, that's the who viewed my profile module. You can use Play's router to get to the controller, call the controller, and aggregate dynamic modules. It doesn't have to be hard-coded. You can even bring in modules from completely separate servers. So for example, the LinkedIn header and footer, the common site header and footer, this was written before we had Play. We've had this thing for years. It's on some Spring MVC JSP app. We can't directly pull it into our Play app. But we can make an HTTP call to it, get back some markup, get back some headers that tell us what it depends on, and aggregate it together. So you can share things as a service. You can have UI as a service. And from AJAX endpoints as well. You can, from the client side, call and maybe pull in a module and pull in its dependencies. So these are very, very reusable. They're very much standalone. And you have this beautiful abstraction and composition. Some of the caveats are putting the static content in a controller is a little weird, but not a big deal. Okay, so that's the basics, the setup for composition and abstraction. The next one to chat about is performance. So we've been using this mock endpoint for all of our service calls. And if you look at this mock guy, I've just been setting the delay to 1 millisecond for all of these services, so they're blazing fast. But what happens if they get slow? Let's kind of take a really extreme example, and we'll make the search service take 3 seconds to respond. So if we go to the Who Viewed My Profile module and I refresh the page, it's going to spin, and then finally it's going to render. So let's look at the water flow chart really quickly, refresh the page again, nothing, 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 and then at the last second we get our response. So here we waited 3 seconds, and if you notice, even the CSS doesn't start loading until 3 seconds later. And that seems like a bit of a waste. Obviously something has to get slower if the backend service is slow, but why does everything? If we look at the markup that we're returning, we get nothing, we get this long pause, and then we get the response. Well, search is all the way down here. Is there a way that I can return all of this stuff immediately without having to wait for search? And it turns out Facebook published a blog post talking about how to do this. Here we go. It's something called BigPipe. How many of you guys have heard of Facebook BigPipe? So maybe 10 people? All right, Facebook's PR needs a little bit of work. This is actually really, really cool stuff. They published this in 2010, and it's actually a way to solve this problem. It's a way to stream parts of a page as soon as they're available. And this is incredibly important for getting the most performance out of your app. And so the question is, can we build BigPipe with Play? And, well, I mean, I'm doing the talk, so obviously the answer is yes. And so what we're going to use to do that is something called enumerators. So let's chat a little bit about enumerators. Enumerators are part of the Play iteratives library. It's this scary thing that Sadek told us about yesterday. But actually, the enumerators part of it is pretty straightforward. I don't think you guys are going to struggle, even if you haven't seen it before at all. So really quick review. An enumerator is a producer. It's something that can produce chunks of data when they're available. An iterative is a consumer. It's the opposite. It's something that consumes chunks of data. And we used one earlier to pull in the body of a module. And then there's also a thing called an enumerative. This is an adapter. It can modify each chunk on the fly before it gets to an enumerator or an iterative. And I find that this diagram is fairly helpful as kind of the mental model of what these things are. The enumerator, that's up here. That thing is a faucet. So enumerators are faucets. They just pump out chunks of data. Iteratives are the glass. They consume all the water. And then the enumerative, it's a little adapter. You can actually attach it to the faucet or to the glass, and it'll filter the data going through before it gets to those guys. So that's what these concepts are about, but the really important thing about them is that they're composable. So we've been talking about composition over and over again, and this is just an essential concept. We can put 2 enumerators together, or 10 enumerators together, and this proves to be kind of the key feature that we need. So let's look at a couple examples just to get you familiar with enumerators. So we'll create one more controller. We'll call it enumerator. Another action. Okay. And what we're going to actually return is not just a 200 OK, we're actually going to use OK.chunked. And if you look at the signature of OK.chunked, it takes in an enumerator of some sort of content. So Play has native support for this. And so we need to give this guy an enumerator. And there's different ways to build enumerators. And the simplest one is just to give it a fixed set of data. This is sort of your base case. So we'll do enumerator, that guy, and we'll just give it, the text, hello, and I don't know, a new line. So this is a really simple case. I believe I need another one of these guys as usual. And let's add this guy to the routes file. And I'm going to use curl to look at this because it's a little easier to see what's going on. And I'm going to use curl-n. If you're working with streaming data, this is a really useful parameter. It tells curl not to buffer anything. And that way, if you only send a little bit of data, curl will tend to buffer it. So this says, don't buffer anything. Show me every chunk of data you get. So if I hit this endpoint, I just get hello. Not a very exciting example. Let's look at something slightly more interesting. We'll add another action in here. We'll call it infinite. And we'll return OK.chunked. And we're going to use another method to create a enumerator called generateM. And if you can see the signature up there, it's something that takes in a function that returns a future. And so play is going to keep calling this function, and I'm going to keep giving it back futures. And when those futures redeem, play will stream the contents of them to the client. And so all we're going to do is we're going to use promise.timeout, this guy, to return just the word hello every 500 milliseconds. So if we add that guy as an endpoint, we're going to get something a little more interesting. So every half a second, we're going to get a chunk of data. So this hopefully gives you a better feel for what an enumerator really is. It's something that can stream data in chunks. And the most important part of enumerators, as I mentioned, is that you can compose them. So we can glue two enumerators together. There's a couple ways to do it. One of them, so we'll call this our hello enumerator, but we can also have another one called goodbye. And what we can do is we can create a new enumerator from them by taking hello and then calling the and then method and giving it another enumerator called goodbye. So this gives us a new enumerator that'll have all the data from hello and then all the data from goodbye. So we put that in here. We call that endpoint, and now you get hello, goodbye. The other way to compose enumerators is to use a method called interleave. So let me give you a quick example of that. Goodbye. Let's make this guy slower. And now what we're going to do is we're going to do enumerator.interleave hello and goodbye. And this is going to return a new enumerator that'll stream data from whichever one of those other guys happens to have it. If hello has data, it'll start streaming it out. If hello pauses and goodbye has data, it'll start streaming that out. It can happen in whatever order. So if we put that in here, and we go here, what you're now going to see is every half a second we're going to see hello, and every 2 seconds we're going to see goodbye. And this will go on basically forever. So hopefully this gives you a flavor for enumerators. Hopefully they're not too complicated. They just pump out data and you can stick them together. Okay, how is this useful? Well, in this controller, this Who Viewed My Profile controller, when we make these service calls, we get back a future of a string. And it turns out it's really easy to create an enumerator from a future. So let's give that a real quick try. What we're going to do is we're going to take the future, we're going to call map, and so there's some kind of a string inside of this future, and we're just going to turn it into an enumerator. So we're just going to do string plus, we'll just add a new line just to make things easier to read for now. Import that guy. And what this is going to give back is a future that contains an enumerator. And enumerator has a cool method in it called flatten, which takes in a future of an enumerator and gives back an enumerator. So if we call this guy, what we're actually going to get is an enumerator of a string. So we went from a future of a string, so something that'll eventually contain a string, to an enumerator of a string, which means something that can stream out the contents of the string. And we can do the same for the other guy, for search. This will be the search future. And then we're actually just going to return these guys in here just so we can see what it looks like, to see if things are working. So we're going to do ok.chunked. And first let's compose these enumerators. So we're going to do Who Viewed My Profile, and then after that has streamed, we're going to do the search enumerator. And we're going to return those right now just directly. So we can get rid of all of this. And we're not actually returning a future anymore, so we can get rid of that. And let's see what it looks like. Oops, wrong endpoint. We want that one. Okay, now did you see what happened here? I got 56, and then 2 seconds later, I get the number 10. So as a reminder, what we're looking at is 56 is the response from the Who Viewed Your Profile service, 10 is the response from the search service. So even though one of them is really fast, one is really slow, I get a response immediately, and then eventually the second one comes along. But here, this isn't very interesting. We're just spitting out the data. We preferably want to render some HTML. It's a little tricky to stream HTML by default the way Play is set up, because HTML in Play is represented by a class called HTML, And it's just a wrapper for a string. And so there's no easy way to just shove an enumerator into a string. But play lets you define a custom template type. And so we're going to actually take advantage of that. And this is really cool. So if we go into the build file, build.sbt, we need to add one line to it. And this says, hey, play, look, I have a new template type. Instead of .scala.html, I'm going to have something called .scala.stream. And you're going to know how to process it using this class I defined called HTML stream. So let's look at that guy. This is one of those helpers I defined earlier on. So here's HTML stream. When you define a new template type, you need to give play two things. One is an appendable. This is basically something that can be appended, something that can be glued together to create, the output of your template. If you look at the class, it's really a really simple trait with one method, plus equals, append. Now the default one built into play is that HTML class that I showed you. If you look, you can see it extends appendable. And it defines plus equals just by adding things to this string builder. So we're going to define an appendable that's a wrapper for an enumerator of HTML. So instead of a template that consists of a bunch of HTML, it's a template that consists of a bunch of enumerators of HTML. And our append operation is defined through this and then method. It's basically just enumerator dot and then. That's how we're going to glue a bunch of streams together. You also have to define a class called a format. And this is basically to tell play, given a string, how do I create one of your appendables? And that's a really straightforward implementation. You just wrap it as a HTML stream. There's a few other helper methods in this file, mostly just to have convenient ways of creating a stream from a string, or from HTML, or from a future of HTML, just a bunch of nice helper methods. We also expose on HTML streams an interleave method, which is exactly the same as enumerator, interleave, and a flatten method, which is exactly the same as enumerators. So here's how this is going to be really helpful. We're going to be able to go in here, and instead of creating these enumerators, we're going to create HTML streams. And we're going to do it like this. We're going to call HTML stream. And instead of wrapping this as an enumerator, we're actually going to render a partial right in line. So if you remember, I have this little partial template that renders just the who viewed my profile count. So we can actually render that right here. Views.html, who viewed my profile count, and we give it some data. Okay, and now we'll do the same thing here, except we'll render a different partial to render the search count. Oops. Views and HTML. There we go. Okay, so now we actually have two. These aren't enumerators anymore. These are streams. This guy as well. Okay, and we've composed them together just like we did before. And we can actually return them and just see what we get. Yes, to return them, I need to import a little implicit conversion. And this basically, it's one method. It converts an HTML stream into an enumerator so play knows how to return it. So if we give that a shot, what you're going to see is the HTML is going to start streaming. We've now streamed out the HTML for two of those modules. So now we just need to wrap it in something. So what we can do is we define a new template, and it's called whoviewedmyprofilestream.scala, not .html, but .stream. This is that new template type that we added. And in here, as an input, I'm going to take another HTML stream as a parameter. For some reason, IntelliJ doesn't see this import, but it should compile. We have our HTML. Actually, let me just copy. This is the original template. Put some markup in here. Borrow this guy. And okay. And then we're just going to put the body inline. So basically, we have a bunch of HTML mixed with a stream of data. And if we render this, we're going to get a streaming page. So now we're going to do views.stream.whoviewedmyprofilestream. We're going to pass it the body. Not sure why IntelliJ is not happy, but hopefully this will work. And now if we refresh, oops, wrong guy, this guy. we're streaming. So if you notice, you may have missed that the first time, the who viewed my profile count is going to appear immediately, and then a few seconds later, the search count is going to appear. So let's look at that again. There's the who viewed my profile count, and now a few seconds later, the search count pops in. And if you look at the response time, we started to get the response almost immediately after 4 milliseconds. And really importantly, we start to load the CSS in the header almost immediately. So instead of waiting 3 seconds for everything, we actually send a response almost as quickly as we can, and then we stream the body as it becomes available. You can see that in curl as well. You see that we got a response right away, and then a few seconds later, we get the rest of the response. So this is a huge performance win. But we can do even better. So here, we're kind of lucky that the slow part was search, the one at the bottom. But what happens if it was the who viewed your profile service that was slow? Let's give that a really quick try. So we'll change this guy to be slow. This guy will be fast again. If we try that, now you see that we still get a response, but we have to wait 3 seconds for everything below it. Take a look at that in curl. We get the top part of the response immediately, but the rest takes a few more seconds to come and stream down. So we still get some wins. You know, the style sheet can start to load immediately, and the user gets to see a little bit of the page. But it would be cool if we could stream these individual modules in any order we wanted. Basically, as soon as they're available, we send them to the browser, and somehow they'll just pop into the correct locations on the page. And we can do this using JavaScript. So, and this will bring us pretty close to what Facebook BigPipe is doing. One thing that I defined ahead of time is this template called pagelet.scala. This thing takes in a snippet of HTML that you want to render and a DOM ID. And it's going to inject your HTML into the page in a way that's invisible. So I'm just using a script tag that's not text JavaScript. It's just some content type I made up. The browser will pretty much ignore this entirely. So it's going to inject this into the page. And then it has some real JavaScript code that's going to set the inner HTML of that DOM node to the markup that's in here. So if we wrap each part of our page in this little, basically these script tags, then we can send them back in whatever order we want, and they'll just pop into the right places on the page. And we have a helper in here in this pagelet class called render stream, where you give it something that has HTML, you give it a DOM ID, and it wraps your code in these script tags and gives you back an HTML stream. So if we use this helper here, so pagelet dot, hello, there we go, render stream. We need to give it a DOM ID. We'll call this who viewed my profile stream. Actually, count is probably a better name. And replace this guy. This is search count. And the only other change we have to make is instead of putting one stream after the other, we can now interleave them and send them down in whatever order they happen to finish. So we can call HTML stream.interleave, do one stream, then the other stream. And now we go into our streaming template. We actually probably now want to put this at the bottom because we don't need it to block any HTML. Order doesn't matter anymore. And now we put in a couple placeholder divs. This is where the content will actually get inserted. Who viewed my profile count and search count. There we go. So now, let's see if this works. Okay, there we go. So now if you notice, this guy's visible immediately because the search service is fast, who viewed my profile is slow. So now they're appearing out of order. See that again? You can see that this one came down first. And if you look at the markup, you can see exactly what's going on here. We got the top of the page, we got our placeholders. Immediately, we got the search results wrapped in script tags. And then a few seconds later, the who viewed my profile results come down, also wrapped in script tags. So this is, skip all that stuff now. Where are we? What the heck? There we go. Okay, yeah. So we have the basics for Facebook BigPipe. It's the ability to send these little pagelets, these little pieces of a page down as soon as they're available. And then they render a lot faster. Your static content starts to load a lot faster. You can start loading images earlier. You just get a huge performance win from doing this. And the code doesn't actually look that bad. Your templates still look like templates. You just have to break them up into partials, which is a good idea anyway to avoid this huge JSP mess that can't compile. Your controller looks like a controller. You make service calls in parallel or in whatever order you need to, and then you just wrap things in these little pagelets using a helper. And when you're done, you interleave these streams, and they can stream down in whatever order you want. So, some of the wins. The time to first byte is dramatically faster. When in the original implementation, it took 3 seconds for the browser to get any sort of response. Now we respond in 5 milliseconds, and the browser starts working after 5 milliseconds. Static content starts downloading after 5 milliseconds. Huge performance gain. Static content loaded faster. The user can actually see the page earlier, which from a perception standpoint can make them think your site is a lot faster, even if individual services are slow. And if you use the out-of-order rendering using JavaScript, you can do some really deep, interesting optimizations. And I recommend you guys read the blog post by Facebook. They talk a lot about how they handle CSS and JavaScript dependencies. So for example, I mentioned adding them as headers. If you do that, then your JavaScript code client-side can intelligently start loading all of this content. At LinkedIn, we also use client-side rendering using Dust templates. And so actually what we can stream down, instead of pure markup, is just JSON data. And the rendering can happen in the browser on the client side. And it can start happening in any order at any time. The JSON parsing starts earlier. So the performance gain here is enormous. There are a few caveats, though. Everything comes with a cost, so you should be aware this does change some things for the worse. So one is if you've streamed out your response immediately, you can't change your mind later on. So if you send back a 200 OK, and then one of your backend services completely fails, you can't change that to a 500 error anymore. Your response is out, it's gone. And similarly, if you already sent the response, you can't add cookies to it anymore. So if you only can set cookies after fetching some sort of data, then all of this kind of stuff you're going to have to start handling client side. So you're going to have more script tags that you inject that write a cookie or redirect the user to an error page. So that's a little clunky, but it's manageable. You do have to be careful with pop-in. So this user experience, it's a lot better than waiting 3 seconds. But if I was trying to click something here and then all of a sudden something just pops in, it kind of gets in the way of the user. So you may want to write your JavaScript code to be a little more intelligent about when it inserts the markup into the DOM. You might not want to do it immediately. You might, for example, check if all the stuff above it has been inserted into the DOM. If it has, you can insert it. If not, do it later. But you've still processed all of its dependencies. You're still loading everything. So you're still going to have all the performance wins. You have to handle CSS and JavaScript dependencies differently, as mentioned before. Testing does get a little harder here. If you're using this streaming approach, your page is no longer the fixed markup that you expect it to be. Your page becomes this sort of out-of-order script tag mess. It's still usable, you can still read it, but you have to change your practices a little bit. You have to change your debugging practices a little bit. And the final thing to be aware of is this can have an impact on SEO. If all of your content is handled client-side and it's a Google bot, you need to do something a little more intelligent to avoid that. And there's various solutions you can try to handle that. Okay, so if you guys want to play with any of this code, all of these helpers and some of these examples are in this GitHub repo. It's just a sample app, so this isn't like an open source library that's ready for use in production, but maybe we'll turn it into something like that in the future. That's it. Thank you very much, guys. Are there any questions? There's a couple here. Do we have a mic for these guys?
Yep.
Awesome.
I was thinking to ask, because I thought everyone else was afraid to ask a question. What's your take on iframes in this context, as opposed, we're just putting aside the extra number of connections going on? I'm sure you guys consider that.
So as an alternative, you're saying building your page out of a bunch of iframes?
Yeah.
I'd have to measure it. My suspicion is that's not going to perform as well for a number of reasons. The main one that would never work, for us at least, is a request comes in and we fan out to a whole bunch of back-end services. And a lot of those are kind of duplicated requests, but we dedupe them in this one request. If instead of getting one request, we got 10 from 10 iframes, then we're going to increase the load on our backends by 10x, because now caching those requests and deduplicating them is a lot more complicated. You need some sort of a key value store, and you have to invalidate the cache, and that's much harder. So that would increase the load on our backends, all of our services, dramatically. I also suspect the user experience with iframes won't be as nice, but I haven't tried it, so I'm not sure what the implications will be there. There's also going to be weirdness building your page out of iframes if the page needs to share static content. You're going to have to load the same static content everywhere. If the JavaScript inside of an iframe needs to talk to the JavaScript outside of an iframe, that's going to get messy. I suspect, having not tried it, I would guess that that's not going to be a very effective approach for building a page.
Okay.
So you mentioned there are workarounds if one wanted to work with like CEO services like Google. So what would be one approach to allow this to render at server side?
So how do you handle Google, essentially?
For example.
There's a few approaches. So one is simply have the user specify the order things should render in. And essentially, if it's not Googlebot, you use interleave and wrap everything in JavaScript. And if it is Google, you use and then, and you don't wrap things in JavaScript. That's one way to handle it. And you still get pretty good performance out of that, so it's actually not a bad experience. Another option, we do client-side rendering for a lot of this stuff with Dust templates. And we actually have a thing called ATS, the Apache Traffic Server, and it's kind of the load balancer for the whole site. And we have a plugin in there called, delightfully nicknamed, USSR. It stands for Unified Server-Side Rendering, and it's an embedded V8 engine, so the thing that powers Chrome. And that thing can render JavaScript and process JavaScript server-side. So if we detect a Googlebot, we can actually handle the JavaScript code in ATS and then send back the fully rendered page, stream it out from USSR, technically. I don't know which approach is better because it's still kind of experimental and we haven't really dealt with it too much. There may be other ways, but those are the two that should work reasonably well.
And my other question is about the edge caching, like how this approach could be combined with like caching.
Caching in what sense?
For the whole page. So how could I basically cache the whole page once it's available?
Good question. We don't cache much of our stuff just because every page on every request is 100% dynamic. So we haven't tried. My suspicion is you actually may be able to do very fine-grained caching of each module. So the two things that I talked about here, the first part about composition and the second part about performance, they actually work really well together. If your page is broken into a bunch of small modules, then you can stream each module down individually. In theory, you should be able to cache each module individually as well. And you can say, hey, look, this one's always dynamic and this one is not. Cache these things, don't cache those. I haven't tried it. My suspicion is that should work reasonably well.
Is there a problem when two modules try to communicate on client side?
When two modules try to communicate? Depends how you set up the code. If you use something like, so you have to do the thinking ahead of time, obviously, but if you use, for example, an event-based system, Backbone, all of these frameworks tend to have one. If the modules don't communicate directly, but just fire events into Backbone, then you have a really nicely decoupled system, and whoever cares about the event just listens for it. And they don't need to know directly whether that module did or didn't load, if it's on the page, if not. They're just listening and firing events. There's other ways you can set up the JavaScript to let them communicate, but that's a pretty effective one.
One question I would have is about the discipline that you need to have if you go for this approach, because I imagine you will have a larger team working on all of these little modules I guess you would split eventually the work, but you probably need a consensus when it comes, for example, to CSS. You don't want to sort of have, do you have each little module really loading each little piece of CSS in place, or do you do this once? Do you sort of have one mastermind kind of thing, pulling things together in the build, or?
You definitely have to have, you have to think these things through ahead of time. In other words, if you just throw together a bunch of stuff, it'll work, but it might not be very efficient for the reasons you mentioned, lots of duplication and things like that. So, one of the techniques that I showed is if each module returns its CSS dependencies as just URLs in a header, then the aggregator can actually deduplicate those and return something that's efficient. In theory, you could do some logic around there. You could just have a common style sheet. So this is like a really simple solution, right? If you have a common appearance for all the modules on your site, for all the headers on your site, some sort of a template for what your page should look like, then you can have all the common stuff in a single style sheet. You call it common.css. If each module depends on common.css, you'll only load it once on the page, and all of them will be able to use the styles defined in it. If the module needs something special to the module, then it'll have, mymodule.css, and nobody else will depend on it or use it, and that's kind of the semantics that you want. So it's solvable, but it does take some thought ahead of time. So I'm pretty much out of time. Maybe one last question, if there are any. Nope. Okay, cool. Thank you, everybody.
All right, great talk, great talk. Okay, everybody, so now we have James Roper, who of course is the tech lead on the Play framework from TypeSafe. Give him a warm welcome.